Hi, thanks for coming. This talk is pre-evaluation in Ruby, which is not really a thing, but it's gonna be after you see this talk. My name's Kevin Deisz. I'm at KD Deisz. I realize that's a weird name, but it's German, so what are you gonna do? You should follow me on the internet. I work at a company called Culture HQ. We're based out of Boston, Massachusetts. We work on making culture better in the workplace. If you're interested in that kind of stuff, you should check us out. Also, I'm from the US, and if any of you guys want to trade Pokemon and Pokemon Go, that's a cool thing too, so come see me after. I'm still looking for region exclusives from here, so anyway. So let's start with MinSwan. So Mats is nice, so we're nice. We're going to write a compiler that understands this sentence. So compilers have a couple of pretty standard steps. They're going to do lexical analysis to determine the tokens. They're going to do semantic analysis to determine the abstract syntax tree. They're going to generate instructions for the virtual machine. They're going to run a couple of optimization passes, and then they're going to execute. So in order to actually understand this sentence, we need to start at the very beginning. So we're going to start with lexical analysis. Lexical analysis means taking this sentence, breaking it up into individual tokens, and then understanding what each of those tokens means. So the first one is going to be a noun, then we're going to have a verb, then we're going to have an adjective. This is a conjunction or an adverb, depending on who you ask, and so on and so forth up into the period. Okay, so we have our list of tokens. We're going to take that and we're going to apply a grammar. So this is the process of semantic analysis. Semantic analysis means that we're going to look at certain parts of this. Like for instance, we're going to start here, and we're going to determine what this means. So we're going to apply a grammar. We're going to call this a verb phrase. It is the combination of a verb and an adjective. Right? So we have these tokens, and we're going to say, okay, those are verb phrases. And these are tiny little trees. Now, if we add our nouns in, we need another token. We need another understanding of that tree structure. So we're going to go back to our grammar, and we're going to add another rule. And this is going to be called a subject phrase. It's a noun into a verb phrase. And so now we can start to build up our tree a little bit more. And so we add in the so, and we need a word for this, and I had to look this one up. Turns out it is a subordinating conjunction. That doesn't matter. What that is to say is that there are two phrases, and there's a word in the middle that joins them. So we go back, and okay, we have a word for this now. And finally, we can go and we can add our period in. We can make a rule for that and say, okay, this is called a sentence. And now we have our tree. And this is our abstract syntax tree for the weirdest English grammar ever. And if we look at this, these are the rules for this grammar, and this is the entirety of the rules for this grammar. It's very limited, but it does, in fact, understand the sentence, provided you had like a very good lexer with a lot of dictionaries. And this looks very similar, right? If you go to RAC, they have this in the examples, and it's just a calculator. But you can see how the grammar kind of aligns. Or this is straight out of Ruby's parse.y, which parses the arithmetic expressions out of Ruby. So, okay, so we've generated our grammar. Next, we need to go and generate instruction sequences for our virtual machine. So taking our existing structure, we can go down to the bottom of the tree, and we need to determine what this is actually going to do. And since is and are really the same verb, and we have some adjectives, we're just going to say, okay, for verb phrases, we're just going to push some attribute onto the stack. And then if we go back to our subject phrases, we're going to say, okay, we need to take that attribute that we pushed onto the stack, and we need to save it into that element that is on the left side, and that we're applying the attribute to that noun. So we're going to say, okay, we have this subject phrase, and we're going to save the attribute by popping the attribute off the stack. And okay, so we've got that done. we're going to go into our subordinating conjunction, and we're going to say, okay, what actually is happening here is the second statement is true because the first statement is true. So really, this is kind of an if statement. The right side is only true if the left side is true. Okay? So we'll add our subordinated conjunction, and we're going to call this a con skip. What this really means is I'm saying skip the second half if the first half isn't true. Okay? And finally, we can go and add our sentence, and we'll add a rule for our sentence, and we'll say we'll just trace that. And now we have a really full-out grammar for this really terrible made-up language called English. And so this is our tree. This is our abstract syntax tree. And what we're going to do is go in and generate those instructions. So we'll start at the top. We're going to take care of the sentence node and just walk down the tree and start to generate things. So we're going to push an attribute nice. We're going to save that attribute, conditionally skip the next two instructions, and grab all of our instructions. And then this is the virtual machine instructions that we're going to execute. Okay, so what we've done so far is we've taken the raw source, we've generated tokens from it that understand what kind of pieces of language each one of them is. Then we've applied a grammar, generated an abstract syntax tree, walked through the tree, and generated instructions. And the last part of this is optimization. And different languages handle this differently. Ruby has a couple of optimization things that it does, especially when you look at MJIT. But there are a lot of things that it can't do. And we're going to look at those in a second. So first of all, let's look at our instruction sequences. All of this is going to execute at runtime. So when we go and execute our program, these things are all going to run no matter what. But the thing is, we have some prior knowledge about this. We know what can be executed at compile time because we can assume Mats is nice, right? I mean, this is like saying like sky is blue. So what we're really saying is this is a constant value. And so we can just go ahead and strip that out and move it on up. So we are nice. Now, the grammar itself does not allow us to make this optimization because the grammar says that we could say Mats is not nice. We are operating under an assumption that he is. Now, those assumptions don't work in all cases. But for our purposes, we're saying they do. We're going to operate under certain assumptions in order to make certain optimization passes. We're going to opt into those optimizations. All right. So let's look at Ruby. The canonical example here is constant folding. So if we look at this statement, we should just be able to put hello world every time. And if we go into getting the actual instruction sequences, you'll see that that is not the case, right? We have a lot of things that we're doing. We're pushing things onto the stack. We're adding them together. We're comparing them against another value. And the reason that we have to do this is because people can do silly things in Ruby. They can do very silly things. So if we look at this and we say, OK, actually, I just want to replace this with true, then this will work in most cases. We have to assume that it will work. But then someone can tweet out this. And then someone can write this. And now 5 plus 3 equals 2. Because you can arbitrarily pull things off of Twitter and evaluate them. Don't do this. What we really need to do if we're going to do this the right way, if we're going to handle all cases, is we need to go into our instruction sequences and we need to do a process of like speculative instruction generation, deoptimization. We can go in and we can say, OK, we're actually going to always call it we're always going to call it 8, but then we can deopt back if the integer plus operation gets ever overwritten. And oh my gosh, great, we've handled all of this. But the question is, why would you ever do this? You wouldn't. And so, we can talk about deoptimization and speculative instructions and lots of nice techniques all day, but at the end of the day, raise your hand if you have, in a production application, overwritten integer plus. Raise your hand if you would care if we just did that optimization and you didn't know about it. Like, this is the thing, is we're catering to a lot of weird things that people could do. And I don't want to cater to those people. I don't particularly care about those people. If you are doing weird things, then you deserve to get burned. That's kind of where I'm at. So I wrote a gem. It's called Preval. It's on GitHub. You can look at it later. And what Preval does is it looks at your code and it says, okay, are these things that we could do at compile time, and are these things that we need to do at runtime? And it uses Ripper, which is internal to Ruby and generates the abstract syntax tree like we did from earlier. And it takes it, and if you go and run that function, you'll get this, which is basically a list of, it's actually the tree structure that gets evaluated. So looking at this tree, in general, you would have to leave it as it is if we're going to support all of the potential possibilities in our grammar. So what I did was I took this and extended Ripper slightly to get a list of nodes. So we take Ripper, we overwrite a whole bunch of methods that occur whenever you hit a certain part of the abstract syntax tree and generate a bunch of nodes. Great, so we've got our nodes, and then we go into the nodes, and we need a way to go from source to AST, we have Ripper, to go from AST back to source. And there's been a whole bunch of people who have done this, and a whole bunch of ways to do this, right, if we look at this. But I just built my own. So it's basically a giant case statement. Every single possible node type, it's generating valid Ruby, and it's just a little bit of code. But the important thing is this doesn't have to be pretty code. This is just valid code, right? So 1 + 2 doesn't have to have spaces in it. No one's ever looking at this. The only time this is ever occurring is once the Ruby VM sees it, but before it compiles it. This is where I shamelessly plug other open source projects. I wrote Prettier for Ruby. It's an auto formatter. You all should check it out. It does nice things, like takes that thing up top and turns it into the thing below. It's an auto formatter. It pretty much gets rid of the need for all the style rules and RuboCop, which you can totally stick to RuboCop if you like waiting forever for it to format. So no, this isn't Prettier Ruby. This is ugly, so I'm calling this uglier for Ruby. All it's doing is generating source code, but it's generating valid source code, at least hopefully. So okay, so what we can do now that we have the capacity to go from source to AST and back to source is we can start to do weird things. We can write a process method that takes in source, runs it through our parser, and generates it back to source, but then around that we can wrap a whole bunch of visitors that will run through each node and do any kind of things that we want to do. So if we look at the node class itself, what it's going to do is call into certain methods for each of the visitors. And if we look at the very simplest one and we go back to our example, this is going to check for a binary operation inside of the abstract syntax tree. And if the left side is an integer and the right side is an integer, we can go and compare those values and then just return the value. Now, this visitor will break your code if you overwrite any of the integer arithmetic expression operators. But I don't care about that. Because if you're going to do that, then you'll just opt out of this part of the code. But this also allows you to do things like if you have like a milliseconds to days converter, you can write 24 times 60 times 1,000, right? You can go and write those things, and you can still get the benefit of just one instruction without having to worry about whether or not the VM is optimizing it or not. OK, so I'm going to switch over to a little live demo here. Hopefully, I won't lose my presentation. Hold, please. We had some technical difficulties before, so we're going to make sure that this works. So inside of the preval, does this work? Oh, yeah. Oh. OK, I can't see it on my screen, but that's OK. So inside of the preval gem, there is a small Sinatra app that you can write. And if you look at it, right, we can do things like this, and it will generate that, which is great. But you can also do things like 5 plus 3, and it just returns the evaluated source. Right, you can see as this thing is running through what it's going to do. And you can do all kinds of weird things like def foo. I'm totally typing blind here, so I hope this works. Yeah, so this works. Right, we're just defining a method and returning a value. But if we're going to go and return @foo, really that's just an attr reader. Attr readers are very slightly more efficient than this kind of function definition, so it just goes ahead and replaces it. Similarly, if we go and do this, and we say this, it's not going to do anything. But if that lines up, it actually just replaces it with an attr writer. These things are more efficient. And the thing is, I don't want to care about whether or not I'm writing attr writer. I just want the VM to take care of it. And so these kind of optimizations can just happen in the background. And then I don't have to worry about what it's doing. So this thing does a whole bunch of weird stuff. It also does stuff like if you have a while loop and you're going to do some thing, if you do while true, it's going to replace it with loop do, which is slightly more efficient. But if you replace it with while false, it just gets rid of it, because that will never happen. Right? This is instruction elimination. It's doing all kinds of minor optimizations under the hood. And the thing is, you can just kind of throw this into your app, and this doesn't impact runtime. The parsing and the AST and the instruction generation happens at the compile time. And you might tell me that Ruby is not compiled. And, oh gosh, my mouse is gone. Where'd it go? OK. You might tell me that Ruby is not compiled, but it actually is. It's just seamless. So another part of this gem is it hooks into something called BootSnap, which you all should be using BootSnap. It looks at BootSnap and it says, OK, this is a weird section of the code, but run through it real quick. If you're using BootSnap and if BootSnap is hooking into the compile step, then what it's going to do is overwrite the BootSnap method for converting code into instruction sequences. And instead of just compiling it, we're going to pass it through preval first. So what this means is that all of this execution actually happens at compile time. It happens before, and if you go and dump those instruction sequences out to separate files, then all of this actually happens before your app even boots. So none of this is happening at runtime. If you were here 2 years ago, I also came with other weird stuff 2 years ago and talked about this kind of same technique. There's a gem called Vernacular that I wrote that allows you to add Ruby macros. And then there's also something called Vernacular AST, which allows you to extend the Ruby abstract syntax tree to add whatever syntax you want and then convert that into valid Ruby code. Those things still exist and use this exact same thing. This is just taking valid Ruby code and turning it into other valid Ruby code. The last part of this gem is looking at the individual visitors. And the thing is, as much as I dislike people that overwrite integer plus, I'm still not going to immediately burn them if they're going to use this gem. So this part of the code shows you, like, you have to go and explicitly enable every visitor that you're going to be using. And so arithmetic is going to go and evaluate each of the expressions, and it's going to get rid of like mathematical identities like ×1 + 0. Exponentiation to 0 is always going to return 1 or -1. The adder accessors I already showed. Fasterer is a static analysis tool that will tell you about micro-optimizations that have been measured for your version of Ruby. The preval visitor called fasterer is much in the same vein and replaces a lot of those things. And finally, loops does the things that we talked about. And this is the part of the presentation where I tell you that I hate static analysis tools. The reason I hate static analysis tools is I feel like about half the time that they're being used, it's managers going in and putting them in place so that they don't have to have conversations with you, so that they can avoid having style questions, which is great. You don't want to have style questions. I'm actually kind of on a mission to get rid of all static analysis tools. I want prettier Ruby or Sam Pippin's Ruby format or even just RubyKaigi autocorrect or really anything to just take the place of that, because there's not really a reason to have these kinds of discussions. At the end of the day, it just doesn't matter. And I don't want to have to care about micro-optimizations. I just want the language to take care of that. I don't want to have to care about formatting. I don't want to have to care about any of these things other than writing good code. And so I guess I'll amend my statement to say I hate the current generation of static analysis tools, because I feel like there is definitely a place for static analysis, but it should be doing things that are much further along than what we're currently doing. Right? If you look at linters, they're kind of the natural evolution of, okay, a manager is going to enforce style through code review. And then, okay, well, that is terrible, so let's write a style guide. Okay, that's terrible, let's write a linter. Okay, that's terrible, let's write an auto formatter. All of these things are steps in a natural evolution, and eventually what we should be getting to is I write some code that is horribly inefficient and terribly formatted, and by the time it gets to the virtual machine, it is incredibly efficient and beautifully formatted. And I shouldn't have to care how it gets to that way. As long as I am expressing something that is valid, it should be optimized and working by the time it's running in production. Similarly, if you go back to the original example of Mats is nice, so we are nice, I shouldn't have to say that to you in any kind of particular way for you to understand what is being said. You understand inherently that what I'm saying is be nice. Don't be rude in the Ruby community. And I've expressed it in a certain manner, but it doesn't matter which way I've expressed it because the message has gotten across. Fundamentally, you understand what I'm saying, so it doesn't matter the manner in which I express it or how many words I use or any other part of that sentence that changes the meaning. So I feel like what we're going to need to do for these static analysis tools is move towards something like type analysis, move towards things like auto formatters, move towards things that are going to take care of more of the process of development for you so that you just don't have to worry about that. As long as you're writing valid Ruby code, you're still delivering to production immediately. And I ran through those slides really fast, like 3 times faster than I practiced. So that is all for me, so thank you very much. Happy to take any questions if you have them. Yeah, you want to grab the mic?
So, knowing that I'm asking about kind of an extreme case, have you added enough optimizations to break Rails yet?
I have added enough optimizations to break my own app. I did want to be able to say that I was running this in production when I got here, so I took my own app down accidentally. But then I fixed it. So I am running this in production. Yeah, it definitely breaks stuff, but as long as you're not doing dumb things, then it should work.
Well, right. Rails is often a massive source of dumb things. They monkey patch all kinds of basic library bits. Cool.
Yeah, really, there are a lot of optimization passes that I still want to make with this thing that will 100% break things. I want sub-expression elimination and I want method inlining. And both of those two should have a much more drastic performance enhancement than the current ones of like 3 + 2 = 5. But those kinds of optimization passes will 100% break things. So, yeah.
Do you have a pretty strong idea at this point of which bad behaviors break which visitors, and is that documented?
It's not documented. But yeah, I mean, if you're monkey patching methods that you shouldn't be, there are a couple things that it does that actually should work for all applications. While true, I don't understand how I don't think you can do a def while. But while true should never break. It also replaces for loops with each. But if you overwrote the each method, then technically that would break. It does replaces .reverse.each with .reverse.each. If you monkey patched any of those 3 methods, then it would break. So yeah. I also have dreams of every visitor having its own verification step that just hooks into like integer and hooks into method added and will give you an error on the app boot if you're monkey patching something that would break one of the visitors that you're trying to use, but it's all down the road. Sure.
So the bigger question is like, what's your vision for Preval? What do you want to achieve? And like, do you already see gains in performance? And how does this relate to say like RubyGears in general, which can do to some extent some of what you are doing? Mm-hmm. What do you think of that?
Yeah, I mean, I think that Ruby should be doing this kind of stuff. I mean, especially like while false stuff and until true, all those kinds of things. Like those things should be eliminated from the AST. And I think some expressions are, but most aren't. My dream for Preval is, well, to be honest, my dream for Preval was talking at RubyKaigi. So, but no, my dream for Preval is that it will actually be used in production systems. I mean, I'm using it in one. But I would like these things to get further along. There are a lot of optimization passes that are used in a lot of languages. And I know that Truffle Ruby, for instance, does a lot of optimization passes with allowing deoptimization. I'd like to allow a lot of these things to happen and just go based on the simple assumption that most people aren't going to break it. Because at the end of the day, the Ruby virtual machine can't make these kinds of optimizations for all users. So I want Preval to come in place of that and just handle it for the 99% case.
Right, but I mean, like, there's some optimization that, for instance, I think Preval could not do, which is, for instance, folding reading constants, because constants are reassigned, like, for instance, with autoload during runtime, sometime or for other reason. Or maybe you could say, okay, we don't reassign constant at all, but then that breaks a lot of things.
Yeah.
It's like there's some stuff that basically the VM has more knowledge about and can typically optimize, which is extremely hard in static analysis, right?
Yeah. Yeah, I mean, it's definitely hard. Yeah.
Okay, thank you.
Yeah.
Thanks, great talk.
Yeah. These mics are very low.
Yeah, they're very low. So I was really interested in what you're talking about. I was wondering, there's some spots I find in Ruby, for example, in Rails, there's some hotspots where you have some nice Ruby code, and to make it optimal, you kind of make it really ugly, and then it's faster, right? And it'd be great if that could be pre-opt, so you could leave the nice Ruby code, but before it gets compiled, like this preval or something could like actually change it to the more efficient but really ugly stuff, right?
Yes.
And you could actually keep the Ruby code that we all want, rather than having to create this ugly mess that is faster, right?
Yes, exactly.
But I guess that's probably further. I mean, that's quite a challenging problem, I guess. But
yeah, I mean, this gem comes, like, the main inspiration for this was prepack, which is a JavaScript package that has a baked-in JavaScript interpreter, like a small JavaScript interpreter that actually runs every function as it's defined, checks the heap for which methods were which objects were allocated, and then just goes and creates better instructions. Like, that would be incredible if I had a tiny Ruby interpreter embedded inside of Preval that could do all those kinds of crazy things. I mean, like I have dreams for this thing, be it like way down the road, but yeah, this is V1 for sure.
Okay, thanks.
Yeah.
Yeah, this is Ro. Sorry in advance for my stupid question. I'm pretty sure you covered, but let me double check. In the Culture HQ, are you using Preval with BootSnap in production?
Yeah.
Oh, that's awesome.
Yeah.
Do it improve the performance?
No. I mean, you know, that much.
So do you plan to use eventual type signatures in future Ruby to apply a lot more optimizations?
Yeah, I have strong feelings about that. Type signatures, okay, all right, okay. Ruby is based on method sending, which is fundamentally based around a list of methods and not a type. So I have very strong feelings about this that probably shouldn't get into, but if you're looking at like a string, then you're never going to be able to understand that string actually was has a refinement for this one lexical scope, or you added a method to string or something else. So like having types be the unit of analysis as opposed to a list of methods that something responds to is going to fundamentally have a problem. So the thing is, types gets you most of the way there, and I like it for that because most of the time people aren't doing weird things. Again, like Preval, like you can get really far with types and it will help you with refactoring. But at the end of the day, if we want to support really, really support true type analysis, then we're going to have to start looking at just like method signatures as just the name of the method, and then every single thing is like a structural type. Like it's like a list of things that it responds to. So I mean, the real dream is treating the Ruby source as two languages. One is the actual Ruby implementation, and one is a separate VM that understands everything that's happening and just makes lists of messages that something responds to and then just passes those around. But maybe I'll be back here in 2 years with that. I don't know. But yeah, I mean, that's way down the line, but that's a dream too. Any other questions? Cool. Well, thanks very much. I'm on the internet as Deisz, and if you have any other questions, feel free to come talk to me afterward.